Hi and welcome to this series of videos on GMAT preparation for the quantitative reasoning section. Today we will be looking at the topic of absolute values for the data sufficiency type of questions. There are basically two types of questions in the quantitative reasoning section of the GMAT exam. One is a problem solving where you have a direct question and 5 answer options. You choose the one that suits it best. And the second type is data sufficiency, where you're given a question and you're given 2 additional statements. So, and your job is to check whether the information given will be enough to answer the question. Let's look at how the options look. So, here are how your options for data sufficiency will be. A is when statement 1 alone is sufficient, but statement 2 alone is not sufficient. Option B is when statement 2 alone is sufficient, but statement 1 alone is not sufficient. Option C is when both the statements together are sufficient, but neither a statement alone is sufficient. And option D is when each statement alone is sufficient. And option E is when statements 1 and 2 together are not sufficient to answer the question. So, the first question here is asking, does mod x equal to 4? You have this first statement which says mod of 11 plus x is equals to 15. When mod of A is equals to B, then either A is equals to B or A is equals to minus B. 11 plus x is equals to 15 or 11 plus x is equals to minus 15. So, if 11 plus x is equals to 15, x will be equal to 4, or when 11 plus x is minus 15, you take 11 to the other side, you will have minus x is equal to minus 26. When x is 4, mod of x is 4, and when x is minus 26, mod of x is equals to 26. So, you cannot answer the question. Either x mod of x can be 4 or it can be 26. So, you are not having sufficient data. This is not sufficient to tell whether mod x will be 4. The second statement says 11 plus mod x is equals to 15. When taking 11 to the other side, you have mod x is equals to 15 minus 11, that is 4. So, you can definitely answer the question that yes, is mod x equals to, does mod x equal to 4, but with a yes. So, therefore, this is sufficient. If x minus 3 into y is equals to 0, is mod of x minus 3 greater than y? Okay. So, the statement is, the given question is x minus 3 into y is equals to 0. This means that either x minus 3 is 0 or y is equals to 0. One of these two should be 0. So, this is 0 when x is equals to 3. Now, the question is asking, is x minus 3 greater, mod of x minus 3 greater than y? For the first statement tells us that y is equals to 0. So, either x minus 3 can be equal to 0 or it cannot be equal to 0. You cannot say for sure whether or not x minus 3 is equals to 0 when y is equal to 0. So, if can you tell us x minus 3, will the modulus of this be greater than 0? Since y is equals to 0, this is what our question will become. So, mod of x minus 3 can also be equal to 0. So, and this inequality sign does not have the greater than or equal to, it only has greater than. So, you cannot say for sure if mod of x minus 3 is greater than 0, because in the case that it is, it's a no. In the case that it is not equal to 3, then it's a yes. So, either way there's ambiguity. So, you cannot answer the question of mod of x minus 3 whether it is greater than y or not. Now, statement 2 tells us that x is not equal to 3. So, if x is not equal to 3, then x minus 3 is not equal to 0. Therefore, y will have to be equal to 0. And now the question becomes, mod of x minus 3, is it greater than y? When you know that x minus 3 can never be equal to 0, then modulus is always positive. So, mod of x minus 3, a modulus will always be greater than 0. This will always hold true. So, the answer comes out to be option, this is not sufficient. Statement 1 is not sufficient and statement 2 is sufficient to answer the question. Therefore, answer is option B. Let's move to the next question. Mod of x plus 2 is equals to mod of y plus 2. What is the value of x plus y? Mod of x plus x plus 2 is equals to mod of y plus 2. Statement 1 says that xy is less than 0. Xy is less than 0, that is x into y, the product is a negative number. That means that x and y have opposite signs. Either x is positive and y is negative, or x is negative and y is positive. That's what we are being told. So x plus 2 is equals to either y plus 2 from the statement here, from this piece of information, or x plus 2 is equals to minus y minus 2. In this case, x is equals to y, or in this case, x is equals to y to that side and 2 for this side. Here you will have x plus y is equals to minus 4. So x cannot be equal to y, because from the given statement, that is in the first statement, xy, the product is less than 0, one should be positive and one should be negative for that. So this is not possible. So hence we can say that x plus y is equals to minus 4, and we are able to answer the question, what is the value of x plus y? Therefore, this is sufficient. Statement 1 is sufficient to answer the question. Statement 2 says x is greater than 2 and y is less than 2. So when x is greater than 2 and y is less than 2, can x be equal to y? No. Therefore, x plus y is equals to minus 4 again, and hence again this statement is also sufficient to answer the question. Therefore, each alone is sufficient to answer the question. Answer option becomes option D. Let's move to the next question. What is the value of A? Mod A minus mod B is equals to 0. Statement 1 is telling us that mod A. So this means that mod A is equals to mod B, but we don't know anything about the values of A and B, hence we cannot answer the question what is the value of A. Therefore, this statement is not sufficient. Statement 2 says mod of A plus mod of B is equals to 0. Now, modulus is always greater than or equal to 0, and the sum of two modulus can be equal to 0 only when mod A is equals to 0 and mod B is equals to 0. So the only way this is possible is when mod A is equals to 0. Therefore, A is equals to 0. So we can definitely calculate the value of A. Therefore, this is sufficient to answer the question. Therefore, answer is answer option B, that is statement 2 is alone is sufficient, but statement 1 alone is not sufficient. Let's see what the next question is. Is x into mod y equal to mod of xy? Is x into mod y equal to mod of xy? First statement says that x is greater than 0. So when x is greater than 0, x is equals to mod x. Therefore, x into mod y can be written as mod of x into mod of y, that is equals to mod of x into y. So yes, it is sufficient to answer the question. We can say that yes, this is true. So here statement 2 says that y is greater than 0. So with y being greater than 0, you can say that mod y is equals to y, but you cannot say anything about x. X can still be, mod x can be equal to x or minus x, can still be positive or negative. Therefore, x mod y, we can write it as x into y, but we cannot define it as whether or not it will be equal to mod of xy. Whether or not, we can still not answer this question. So therefore, this is not sufficient to answer the given question. It can still be equal, or it can be equal to minus of mod of xy. So therefore, answer is option A, when statement 1 alone is sufficient, but statement 2 alone is not sufficient. Let's look at the next question now. What is the value of m? We are given that in the first statement, mod of m is equals to minus 36 divided by m, and mod of any number will come out to be a positive, a non-negative number. Therefore, here m must be negative. Cannot be 0, because 36 divided by 0 will be undefined. So m must be negative. Therefore, mod of m is equals to minus m. Now you can substitute that in the given statement. Minus m is equals to minus 36 divided by m. So that means minus m square cross multiplying minus m square is equals to minus 36, m square is equals to 36. That means that m is equals to minus of 6. It can be plus 6 or minus 6, but m must be negative, therefore m is equals to minus 6. So what is the value of m? We got one definite value of m, therefore this statement we can say is sufficient alone to answer the question. Let's look at second statement. The second statement says that 2 of m plus 2 of mod m is equals to 0, which means that m is equals to minus of mod m. That means that m is a negative number. But we cannot, mod m, we can write this as mod m is equals to minus m. We cannot deduce the value of m. We only can say that yes, it's negative, but we don't know, we cannot calculate the value of m from this given statement. Therefore, it is not sufficient to answer the question. Our answer option becomes, answer is option A, where statement 1 alone is sufficient, but statement 2 alone is not sufficient to answer the question. Let's look at the next question now. Is x plus y whole square greater than x square plus y square? So the question is asking us, is x plus y whole square greater than x square plus y square? So let's expand this inequality. X square plus y square plus 2xy, they're asking if it is greater than x square plus y square. Subtract x square plus y square on both sides, you'll be left with the expression 2xy is greater than 0. They're asking, is 2xy greater than 0? So let's look at the information that we are given. The first piece of information tells us that mod of x is less than equal to 0. So mod of x is a absolute value which will always be greater than or equal to 0. A modulus value cannot be negative. Therefore, the only possibility that is left from this expression is that x is equals to 0. When mod of x is equals to 0, that means that x is equals to 0. Therefore, we can say that we can answer the question whether 2xy is greater than 0. We will say no, because x is equals to 0, it is actually equal to 0, not greater than 0. So that's our first statement. And then when you look at the second statement, it says under root of y square, it is less than equals to 0. It's again the same as saying any under root of any number y square is equals to its modulus value, that is mod of y. So it is equal to saying that modulus of y is less than equal to 0. So again, modulus cannot be, should be greater than equal to 0, and the only way this is possible is when modulus of y is equals to 0. That means that y is equals to 0. Again, you can answer the question that 2xy is not greater than 0. It is equal to 0. First statement was also sufficient and second statement was also sufficient to, both are sufficient to answer the questions. Therefore, answer option is D, when both the statements alone are sufficient to answer the question. Let's look at the next question. What is the value of x? First so they're asking us what is the value of x. First statement says that x minus 1 into x minus 2.5 is equals to 1. So let's expand here. X minus 1 into x minus 2.5 is nothing but x square minus 2.5x minus x plus 2.5, which is equals to 1. So you have x square minus 3.5x plus, taking 1 to this side, you have 2.5 minus 1 is 1.5 is equals to 0. 1.5 can be written as 0.5 into 3, and 3 plus 0.5 will give you 3.5. So here you can write this as x square minus 3x minus 0.5x plus 1.5 is equals to 0, which is saying that x into x minus 3 minus 0.5 into x minus 3 is equals to 0. So therefore, x minus 3 into x minus 0.5 is equals to 0. So either x is equals to 3 or x is equals to 0.5. So can you find the value of x from this expression? You having two different values of x. So no, you cannot definitely say which is the value of x. So therefore, this statement alone is not sufficient to answer the question. Let's look at statement number 2. You have mod of x minus 5 is equals to 2. So we know that when mod of a is equals to b, either a is equals to b or a is equals to minus b. So therefore, the statement will be converted as x minus 5 is equals to 2 or x minus 5 is equals to minus 2, which means that x, when you take minus 5 to the other side, x is equals to 7 or x is equals to 5 minus 2, that is 3. So therefore, this is also not sufficient on its own to answer the question, since you are getting two different answer values. So now looking at statement 1 and 2 together, you have the answers that are overlapping. That from first equation you have x is equals to 3 or x is equals to 0.5, and from the second statement you have x is equals to 7 or x is equals to 3. So for 1 plus 2 together, to satisfy both the expressions, we only have the value that x is equals to 3. So yeah, are you getting a definite value of x? Yes, that is x is equals to 3. Therefore, together they are sufficient to answer the question. Therefore, answer is option C, when both neither one or two statements are alone sufficient, but both together are sufficient to answer the question. So answer is option C. Let's look at the next question. So the question is, if mod of x minus y minus 2 is equals to 4, then what is the value of x minus y? Then what is the value of x minus y is equals to what? So as we know that if mod of a is equals to b, either a is equals to b or it is equals to minus b. So x minus y minus 2 is either equal to 4 or x minus y minus 2 is equals to minus 4. From this you will get x minus y is equals to 4 plus 2, 6, or from this you will get x minus y is equals to minus 4 plus 2 becomes minus 2. So there are two different values. Let's check what are the given statements. First statement is telling us that x is greater than y. So it is telling us that x minus y is greater than 0. Out of these two values, that is 6 and minus 2, only one value is greater than 0. Therefore, x minus y should be equal to 6. So this statement is sufficient to answer the question. You get one definite value of x minus y. Let's look at statement 2. Statement 2 tells us that y minus 2 is equals to 4. So this means that y is equals to 4 plus 2, 6. So here you know the value of y, but you don't know anything about the value of x. So x minus y can still be equals to 6. Then x will become 6 plus y, that is 6 plus 6 is becomes 12, or x minus y could still be equals to minus 2. So x becomes y minus 2, that is equals to 6 minus 2 is equals to 4. So you can still have two different values of x, and for this given value of y, and x minus y will take two different values. Therefore, it is not sufficient to answer the question asked. Therefore, the answer option is A, where statement 1 is sufficient to answer the question, but statement 2 is not sufficient to answer the question. Those were a few questions on the topic of absolute values for data sufficiency type of questions. Hope they were clear. Thanks for watching.